Today, Ahmed will share his knowledge about petrophysics with focus on turbidite sequence reservoir characterization, enhanced formation evaluation workflow. Ahmed will discuss this identification as well as the technique in a challenging reservoir like thin and bed reservoir in his study case. I'm sure it's gonna be an interesting topic and discussion, which many of us might know that Indonesia has prolific reservoir as well, with thin bed characteristic in Northwest Java Basin, South and Central Sumatra. But before we jump into the presentation, I would like to remind everyone to mute their microphone during presentation to help maintain the smoothness of the online presentation. If you have any question, please type it under the chat room. Be specific, concise, and clear about the question so that we can answer it very quickly. In the Q&A session, you may unmute yourself and speak about your question once allowed by the host. That is all from me. Mr. Ahmed, you'll have 1 hour presentation. Time is yours.
Thank you. Thanks a lot for the introduction. Can you see my screen right now?
Yes, we can.
Yes. So really, I would like to thank SPE Java and the community about like the invitation. Once I received the invitation, I was like interesting and excited to present one of the good topics. Especially, I know the expertise most of the time Asia Pac, like in Baker Hughes, we have like a different regions. So Asia Pac always have like the expertise. I'm talking about in my domains, in all domains they have expertise, but information evaluation and petrophysics and reservoir engineering, most of the time the expertise are located there. So I'd like to thank for this opportunity to present this, and also yes, I will share my workflow, but also I will share the experience, and it will be 2 ways. It's not like one way to present. So the valuable discussion, everybody will benefit, and I'm happy, and I have no problem to stop me anytime to ask. And if I know the answer, I will tell you like what I know. If I don't know, I will check and I will get back to you. So let's have it like a valuable discussion, not like one way to throw all the material I have. This will benefit everybody. So when I received the invitation, it was like the request mainly about NMR, but I realized that about the expertise there to talk about like the NMR in terms of processing and tools, this will not attract your attention. So the best way to utilize the NMR in approach you are, or in a subject you are interested in this approach. So what I have seen that in your area, the turbidites or the thin laminated shale sand sequence is one of the interesting things. So what I did, I just like used our enhanced workflow. NMR is part of this workflow to evaluate the reservoir. Might be you will find something interesting and you can use it and apply it in your area, and you can benefit your company and your reserve calculation. So I will stick for the time 1 hour. Thanks for that. And as I mentioned, anytime you feel there's a question, you can take a note or you can stop me. I have no problem for that. So our agenda today, it's about introduction and turbidite formation evaluation challenges, and then the multi-component resistivity and the high resolution porosity logs, dielectric and enhanced NMR workflow, and then the conclusion. So most of you are familiar about the turbidite sequence, and just like a brief for who is not familiar about that, the turbidites sediments is like a kind of sediments deposited by turbidity current. And what the turbidity currents, it's like when we have a denser fluids flow through the lighter one, the difference in density prevents them from mixing. So the denser fluid will form a current within the less dense fluids. So the turbidity current is like the dense flow moving or around the less dense one. So any sediments deposited by turbidity currents are known by turbidity sediments, and the rocks formed by these sediments are known as turbidites. So in all deep basin, it's like I cannot say that just like a turbidite, but it's deposited as a thin laminated shale sand sequence. And most of the time based on the existing technology, because it's just very small lamina, the vertical resolution for the existing conventional tool cannot detect this, and it will average the shale and sand. So at the end of the day, any petrophysicist will not be able to evaluate the reservoir. So a lot of bypassed hydrocarbon in this area. So if we can talk about the definition of thin beds, if we are talking geologically, thin beds include all geological beds are less than 2 feet. And petrophysically, any thin beds which defined as sedimentary unit which has a thickness less than the vertical resolution of standard logs. So density, neutron, resistivity, anything below the vertical resolution, petrophysically we are defining as the thin bed. So we are working together to find the workflow and find like which technology to help us to avoid, as you can see, we have 30% of world hydrocarbon reserves are bypassed because of the thin beds. So you can see that here, like how fine and how small the thin beds located from the core, and you can see like just like a small 1 centimeter cores, you can find even up to millimeters shale sand laminar. So we will try to have a combination between the logs and enhance some of the existing logs, and then introduce a new technology which can help us to evaluate the turbidite or the low resistivity bay due to the thin laminated reservoir. So what's the problem of the basic and conventional logs we are seeing? The problem of the conventional logs that all the laminar is less than the vertical resolution or lower than the vertical resolution. So the tool which we are using is just averaging the shale and sand. So if you have like shale has low resistivity and sand has high resistivity, at the end of the day, you are measuring all the traditional logging tool measure the volume or the area perpendicular to the tool body. So what you will do, it's just like averaging the resistivity from the sand and shale. So if you have like 1 ohm shale and 10 ohm sand, you will get something in between your resistivity measurement. And most of the tools which we are using is like seeking conductivity. So the easiest path or easiest way to go through the shale, not the sand. So this will make the problem bigger, and even not the averaging as well, the resistivity will be suppressed or underestimated. Even the porosity tools will average the same like the resistivity. So today, what we are looking to get and what we are looking to evaluate, we need to get the sand resistivity, the laminar sand resistivity, and also we need to identify the sand porosity and permeability. And also we need to, once we have both of them, sometimes, and this is like what I have seen, especially here in our area, we start to dig more for a new area in Red Sea, and there is a turbidite sequence. And yes, we have anisotropy, we have the separation between RV and RH, and we can get the R sand. It's like something potential, but when they try to test it, nothing there. And by cores, by analysis, they found it's a cemented or tight sand. So today we will add for the old, which like nothing new. I'm talking about the sand resistivity using tensor or even the Thomas Stiver, the first approach or early approach, sand porosity and permeability. We will add how to get accurate high resolution porosity, not just like a sampling rate, but the new one is like we need to identify the free fluids. Yes, I have high resistivity, I have porosity, but do I have like free fluids or everything is bound? This is what we will show you today. So the workflow is like composite or like the component of workflow is NMR and dielectric resistivity image layer model and high resolution logs from density, neutron, and acoustic, and high resolution VPVS if we got like the high resolution acoustic, and also the tensor, which everybody familiar, RVRH. Once we are having these inputs, we can get the effective sand porosity, laminar sand porosity, and the free fluids for the sand and the clay bound for the shale, and the amount of bound fluids. Once we are getting at this stage, you are able to get your SWT and SWE, and you can enhance or update your dynamic model, and we can avoid any bypassed oil. So we will start for the conventional one, which everybody familiar. I will not take time about the 3D resistivity, which is triaxial resistivity. We have like a laminated sequence, and we need to get like the RV and the RH. The conventional tool are measuring both the RV and RH. If we are talking about the current technology like induction, the basic resistivity is measuring both RV, RH, the mix. And maybe the lateral log, in 2002, maybe the triaxial resistivity was not exist or still not like applied in everywhere. I was in the Mediterranean Sea, and I tried to resolve the lamination or RVRH by combining the induction, the conventional induction tool with the lateral log to get RVRH, just to understand, just to let you know the challenge. I need to identify my RVRH to get my RSAND. So maybe you have seen this before. We have like 1 ohm shale and 10 ohm sand laminated sequence. So your RH, which is measured by the conventional, or if we have like a clear RH, will be 1.8. If we introduced the triaxial resistivity, which has like, you will see, it's similar to the conventional induction, but we made the coils of the transmitter and receiver in different directions, so we can get or force the current and the waves to measure. Sorry. In different direction, and we can get multiple components. This is why we are calling it multi-component resistivity. So with a different location of and direction of the coils for the tool, we can measure different resistivity, and with up to 9 components we are able in direction X and Y and Z, we are able to get the RV, RH, and from RV, RH, you are able to get your RSAND. And once you are getting your RSAND and you identify your laminar, you are in a good shape at this moment to resolve the effect of lamination or the sequence, the thin bed laminated reservoir on the resistivity. You succeed to get the RSAND. But this is not the case, because might be this sand just like a tight or cemented, and the true resistivity or the high resistivity is just due to tightness. So the next stage after we will go for forward on our presentation, we need to see there is a porosity or there is no porosity. But just before jump to the porosity, this multi-component resistivity can help us to get the RVRH in a vertical well, which the tool or the borehole is perpendicular to the formation, or even deviated and horizontal, because like we have 9 components and we can identify which component, and using the MMF technique to get the rotation for this component, and we can measure the RV, RH easily. I added these 2 slides because most of the time when we presented that, it's just the model, the sketch. We have a tool and we have a thin laminated layers. Everybody feel that once we are in deviated hole or horizontal, it will be a difficult job. No, we can do the same with multi-component resistivity to get the RV or H even in deviated well. So this is the example for the low formation depth and formation angle, and this is the high formation depth. So both of them you can identify your RVRH, and you can identify the formation depth as well. So we will move for the next step in our workflow. We succeed to get the RSAND after removing the laminar shale volume to get the true resistivity of the sand. But we don't know, there's a porosity there, and the porosity has a hydrocarbon. This is why the resistivity is high, or there is no porosity and the resistivity is high due to the tightness. Just like to share with you, in the industry, sometimes maybe without any bad intention, when the client asking the service provider, I need a high resolution log, and the service provider is like to say, yes, I can deliver you a high resolution log. And once the client or the operating company got the logs and still the data, while they acquired like the high resolution mode, and they are expecting that they will see the thin lamina or the resolution will be enhanced, they discovered later that nothing changes. Still is a straight line, and I'm not able to see this resolution. What I'm trying to help here, please just ask the service provider. Yes, maybe high sample rate will be helpful to process high resolution, but high sampling rate is not the high resolution, and I will show you what the difference. So maybe the service provider consider, with no bad intention, that the high sampling rate, instead of 2 sample, 4 sample, 8 samples, this is the high resolution. This is a high sample rate, but not a high resolution density neutron. So in here, we have the density neutron, which is, it's better to acquire with high sample rate, but with some technique between the long space and short space, we are able to get the high resolution density neutron. This is the conventional density neutron, which you are seeing everywhere or every day, 4 sample per foot. And maybe you can see from the density image, there is some layers is density neutron is not able to see, and the resolution is low. So when the service provider telling you, yes, I have a solution for that, I will provide you high resolution density neutron. What he will do, he just provide you a high sampling rate, which you can see that more or less the same, maybe a little bit, but at the end of the day is the same. It's just high sampling rate. It's not a high resolution. But if we enhance it or process the data for high resolution using the relation between the short space and long space, you are getting a high resolution density neutron. And this will make a big difference if you combine it in your Thomas Tybor or even tensor analysis to get your phi max and porosity analysis with the multi-component resistivity. This is the conventional density neutron, and here the enhanced density neutron. So nothing will be different, high resolution or high sampling rate acquisition, but you have to ask, be specific to the service provider, because I have seen this, why I'm highlighting this. We have seen it in the Red Sea that I have a discussion with my client, and he was telling me, I acquired the data in high resolution, but still is a straight line. I'm not seeing the illumination, which I'm seeing on the resistivity image. And when I look, it's just like a high sampling rate. Just consider this in your analysis. For acoustic, everybody knows that all the service provider have this. This is not new. It has been introduced. We are acquiring the distance between the receiver, the transmitter and receiver. We are talking about like 1 foot to 2 foot based on the technology, based on the, I'm talking about the different service provider. But with receiver array position and position transmitter, we are able to, by the way, just like I missed something, this processing for density neutron high resolution is helping you to get 6-inch resolution for the density neutron. The same here in acoustic, or Baker Hughes is calling it acoustic. Maybe you are familiar with Sonic. You are able to get like a high resolution up to 6-inch half foot vertical resolution for the acoustic. And you can see the track on the left. This is the conventional one which you are receiving every day, and the right one is the high resolution 6-inch resolution. And you can compare both of them compared to the resistivity image. You can see the difference and how the impact in your multi-min analysis or in your shady sand evaluation model. So just request this one, don't count that the acoustic might have a little bit better resolution, but there is the processing, and it's just like processing normal acquisition to get the high resolution, to get the data up to 6-inch. And here, like an example to show you like the comparison between the lamination and the high resolution VPVS, and you can see the relation between the reflection of layer. If you have thin bed layers on the waveform, you can see the reflection even it's matching with the bidding on the resistivity image. And VPVS, which high resolution, also is seeing the same. So this will help you to get a high resolution for the density neutron and acoustic. And you can use both of them as an inputs in your multi-min or in your shale sand or sand laminated model to enhance your porosity calculation with this high resolution. One of the interpretation is the high resolution VPVN, VPVS. So if we enhance the compression and shear, you can get from the VPVS high resolution 6-inch, you can get the conventional cross plots, which is VPVS versus acoustic impedance, or even versus DTC. So this cross plot is helping the petrophysicist to identify, do we have sand or shale, and where is do we have because it's a good gas indicator. So if we look for this example, you can see the difference between the black is the normal resolution and the green is the high resolution. And the top part of the non-conventional resolution, you can see the VPVS, anything below 1.5, which mainly sand filled by gas, is a low amount because you are not seeing any of the high res or a small lamina. But once you enhance it, your compression and shear, you are able to identify all the sand layer filled by gas. So this one is like a kind of interpretation using the high resolution plus your using the conventional density neutron, not the conventional, the high res density neutron and acoustic in your model. So maybe on the recent, like on the last decade, everybody start to be familiar about dielectric, and dielectric is mainly everybody you heard about the electromagnetic wave, which we are using the propagation resistivity in LWD. And the dielectric is a similar technique, but with high frequency up to 1 gigahertz. Even there are some trials to get the dielectric properties from the LWD, because it's the same. We are have electromagnetic field, and we are measuring the phase and the attenuation. But the difference between both in dielectric and conventional resistivity is the frequency. In general, low frequency is conductivity will be dominant. High frequency up to gigahertz, the dielectric will be dominant. And once we have the high frequency, we are able to get the permittivity, which is the main dielectric properties. And if you are familiar about the sigma encased hole, the main concept or technique for the dielectric is we have the tool is the sigma of water is high compared to the sigma of hydrocarbon and the sigma of matrix. So if you have a tool measuring the sigma, and you can using the simple equation, you are able to identify the hydrocarbon saturation there. It's the same. We have a big contrast between the permittivity of water compared to the permittivity of oil and hydrocarbons. So with the same concept, more or less, with some differences, we are able to find the water, the filled porosity. And when you will get the water filled porosity, and we came maybe just late with the tool, and when we decide to come with a tool, we need to come with different tool specs. One of the specs will help us for the shale sand lamination, that we add extra frequency, extra transmitter and receiver, which help us to get like 1-inch vertical resolution. So you are able, resistivity independent, you are able to get your hydrocarbon saturation or water filled porosity in 1-inch vertical resolution. So, and you can see the example, even if it's not like the one like similar till now, I'm trying to deploy it in turbidite, but the shale sand sequence, you can see that we are able to identify the hydrocarbon and the water filled porosity there. And also you can identify your M and N, the texture exponent from the dielectric. So this tool is helping you when the resistivity is suppressed. The dielectric can help you hydrocarbon saturation resistivity independent and Archie constant independent. So there is one question maybe I will receive here, like if we have a suppressed resistivity, maybe the signal to noise will be very low, and a dielectric will be like noisy data. This is true. This is like physics, nobody can argue. But we were lucky that we came late, and here in Saudi Arabia we have a carbonate low resistivity bay, which is something different than the laminated cherry sand. It's about the micritic limestone, and the micritic limestone have microporosity, and the microporosity holding saline water. This saline water is suppressing the resistivity. So even the resistivity, you can imagine it reaching to 0.2. And this is a very conductive resistivity. And in 0.2, we are producing oil because everything is bound, fluid. The water is affecting the resistivity is just not a free water. All the large bores filled by hydrocarbon, but from the conventional resistivity, you cannot. So what we did, just we enhanced the bad design to have a good contact, and also we enhanced the tool itself to avoid the noise coming from the conductive fluids. So we succeed to get a good data by this modification. Yes, we came late, like maybe after 7 years from the first dielectric, but we try to make sure that the tool will overcome all the challenges. So if you hear before that the low resistivity bay, the dielectric will not help because the resistivity is low and the dielectric will be noisy, this has been overcome by what I have mentioned about the tool modification. So now we are able to get the sand resistivity, RVRH, and then sand resistivity and shale laminar. We are able to get a high resolution logs, which will help you to identify your tensor and phi max and all the laminar volumes with a high resolution, and also additional tool to provide you a resistivity, hydrocarbon saturation resistivity independent and Archie constant independent. What everybody was interesting, and this is what I will give more weight, and I just combine it with the turbidites evaluation, is the NMR analysis. And this is a powerful tool. When I received the call from my client like 2 years back, and he was complaining about like, how can I know that I have free fluids? There's a production there. Everybody's introducing me RVRH, and some people telling me that we have high resolution porosity, but I'm just putting the well or testing the well and nothing is coming. So I introduced this workflow, and we have utilized this workflow to help to see like where is do we have a free fluids or everything is bound inside the bore space or inside the shale lamina. Just like for non-NMR expert, we are having a big magnet for each NMR wireline LWD. We have a big magnet, and we are activating this magnet. So all the hydrogen inside the bore space, whatever hydrogen in hydrocarbon, hydrogen water, will be aligned with the magnet, because each hydrogen will behave like a small magnet. So they will take the same direction for the strong magnet. And we will switch off this magnet and measure the decay of these hydrogen. And you can see that the decay we are calling, the polarization to have the alignment, we are calling T1. The decay, we are calling it T2. So we are measuring the T2, and with a transform, you are seeing T2 distribution from the T2 decay to the T2 distribution. Maybe like if you are asking the service provider to acquire the NMR LWD wireline, the first question, after all the information about the fluids, the lithology, the inputs he needs to run the planner, he will ask you, what my T2 cutoff? We have two cutoffs, one for the clay bound to identify the clay bound from the bound fluid, and the higher or another cutoff is the bound cutoff, which will differentiate between the free fluids and the bound fluid. Anything above this is the free fluids, anything below this is a free fluids. So maybe this is, you can see that the T2 cutoff for clastic, the industry used like a standard for 33 millisecond, and for carbonate 92. But in carbonate, little bit complex. The standard here in Saudi Aramco, we are using 220. Some formation to do kind of calibration with the core. We reached it for 340. So you can see this cutoff required calibration from lithology to lithology, from field to field, and we should not count for the standard, and then we can blame why the free fluids or the permeability from NMR is not matching my core data or not matching the mobility from the formation testing. We have to identify the right cutoff first and then see the results, because everything will be calculated based on your cutoff. And the standard cutoff is vary from reservoir to reservoir, or from rock to rock, and from reservoir to reservoir, and field to field. So this is like we can see like what you have seen is just a cross plot, but everybody on the industry are receiving this T2 distribution. And the red line is the cutoff. You have seen it differentiate between the BVI and CBW, and the blue line is differentiating between the bound fluid and free fluid. This is what you are getting from the logs when you are acquiring the NMR. So this is the porosity model. We are talking about capillary bound water, clay bound water, and mobile water and hydrocarbon. So if we are talking about total porosity, which include the clay, capillary, and the mobile free fluids, the effective porosity will be excluding the clay bound fluid. Other maybe like in detailed NMR presentation, you will realize that the difference between from rock to rock or reservoir to reservoir for the polarization and relaxation, mainly for the T1 and T2 is counting on three parts. The first one is the intrinsic T1 or T2 fluids. So do we have a dense fluid has a shorter T2, like I have a tar or very heavy oil, or even water is denser, or I have a light hydrocarbon condensate, and I have a gas. The more getting lighter, the time getting longer. And the second factor for the T2 is the bore size. If you have a large bore space, you are getting more time for polarization and relaxation. If you have a smaller time, the relaxation will be very fast decay. So you can see it if we have a shale, the decay it will be very fast because very small and filled by water, and there is no room to take time for relaxation. It's very fast decay. If you have a large bore space, you will take long time to relax. We took from this benefit. The third one is the gradient or the diffusivity, which is like each tool. We will talk about this using multi-frequency, and this multi-frequency creating a gradient, external gradient in the formation. This gradient creating a diffusion. And based on the fluid diffusivity, each fluid will behave differently with this gradient. So this is the three factor. But in a water bearing zone, or on like the NMR depth of investigation just 4 inches, and most of the time is flushed with the drilling fluids mud. We can see that the main variation for the T2 will be mainly dominating by the bore size. If we have a large bore size, will take long time, and if we have a small bore size, will take short time. So we can, in clastics or in shale sand, we can identify based on the time we have a clay or we have a coarse sand. The second one, which we can get from the NMR, as I mentioned, that we are applying a multi-frequency, and we have a gradient inside during the acquisition, and this gradient creates the diffusion, and each fluid has a different diffusivity. So the gas has the highest diffusivity, and the oil, based on the oil density, has a different diffusivity. The industry used this cross plot to identify the fluid type. So if you are acquiring the NMR, you will be able to get the porosity, which is the lithology independent porosity. Maybe I missed to highlight this about the porosity. Density, neutron, and all the other porosity needs to know what your matrix to calculate your porosity. But the NMR, it's just a lithology independent porosity. So you are able to get from the NMR as accurate porosity. You are able to get idea about the bore size is a large or a small bore size. And also you are able to get idea about the hydrocarbon. It's gas, light oil, heavy oil, water. So you can identify from the 2D NMR. And this is the simple example from the plot or the cross plot I showed to you. This is what you will see in if you have like high resistivity and you have the density neutron, and this is not like a low resistivity sand, low resistivity bay, just to show you the contrast. Once we have oil, it's a clear oil based on the oil line or the signal located in the oil line. Once you have water, it is on the water line. The purpose of this example to show you the oil water contact from the resistivity is matching the oil water contact from the NMR. If we will go for the low resistivity bay deep water, the NMR is helping. If you look for this resistivity, the resistivity track, you can see that we have high resistivity and suddenly we have a drop for the resistivity and it's very low. So is the oil water contact is here or below this? So without having like NMR, we will not be able to identify that. And this is a real example. It was just like we need to decide like where the area for the oil water contact is the low resistivity due to free water or something else. We have seen that we have high bound fluid is increasing toward the bottom, which is suppressing your resistivity, but still the large bore filled by hydrocarbon. And this zone has been tested and we increased like 1,500 barrel oil per day based on NMR. So if you will see the conventional logs will not help you to identify there is like extra fluid or hydrocarbon fluid is existing. Maybe like most of you have this challenge that you have a mix of clastic reservoir. One of them is gas reservoir and the bottom one on the same whole section is having kaolinite. And sometimes you feel that the gamma ray is the optimum tool to use for the volume of shale. And some of you feel that maybe the density neutron. Yes, but if you have a gas, density neutron will be underestimating or not accurate for your shale volume index in the gas zone. And also the gamma ray will not be the optimum one in the kaolinite because kaolinite doesn't have potassium, so will not reflect the true amount of volume shale. The NMR volume of shale is very simple and very accurate and can work for both without any issue. You can see it's a simple equation. It's just the volume shale. We are using the clay bound volume over divided by the clay bound of the shale, the 100% shale, and you are able to get your volume shale. Here you can see that we have a gas at the top and at the bottom we have kaolinite. If we'll use the gamma ray, the volume shale from the gamma ray on the gas, yes, reasonable one. We can see that we have a good volume of shale. But in kaolinite is not reflecting the reality for the reservoir because it's kaolinite and the gamma ray is low. If we get the density neutron volume of shale from density neutron, you will see it will not work in the gas because it's the both density neutrons affected by the gas, but might be it will work on the kaolinite section. So you have two options to identify which zone and which tool. Some of them, some of the petrophysicists is using the combination between both of them. But if you look for the volume of shale from the NMR, you can get it all the time is accurate without doing any zonation or considering that which kind of reservoir I have, kaolinite, I have gas. You can use it as a methodology. I'm right now publishing a paper with Saudi Aramco because this is the total volume of shale, and I felt not just feeling, but I have practiced this in several fields all the time. The volume of shale from NMR is more accurate than the other tools. So we have seen that we are able to identify the amount of illite and kaolinite, the clay typing from NMR. And when I introduced this idea to Saudi Aramco at the beginning, they feel that maybe I'm a little bit crazy, or it is a theoretical, can be on the lab, but not like downhole measurement. We have done an experiment in 4 wells versus the spectral gamma ray wireline and XRD, XRF from the core. And also we validate this with the formation testing. And you can see, because maybe you are using the same, I'm just giving you a side note. We are using here recycled mud or K-formate mud. The mud engineer is not able to provide you as a petrophysicist the right amount of potassium. So all the time is providing you, because he has no control for the mud. Something, yani, I have seen it when I was processing the spectral gamma ray and the mineral spectroscopy. I'm asking the mud report, drink fluids mud report, and I got like 3%. But when I process the data, this is not what I'm expecting in my reservoir and not matching with offset. I was just at this time playing with the amount of potassium on the mud. From 3%, I reached it for 30%. You can see the impact on this. When I acquired the mud sample, I sent it to our Dahran Technology Center, and I checked like carefully with a high-tech lab. I found that yes, the potassium percentage is higher than this. And the mud engineer was not cheating. He was not able, because he has no control. The mud is recycled and came to him, the K-formate mud. So everybody, if you are counting on, especially like in the Middle East, to differentiate the productivity or the productive zone based on the amount of kaolinite, you can imagine if you are calculating or correcting your spectral gamma ray with a 3% potassium on the mud, while it is 30%. You can imagine how the potassium will change your clay type. You know, like it's a cross plot between the potassium and cerium. So we proved with the experiment I told you, and inshallah it will be accepted in May's conference, and we will publish this, that the clay typing from NMR in some cases, when the some challenges for the mud, it's better than the spectral gamma ray clay typing. And if it's normal, both of them are matching. And soon you will see this paper published in the conference or in one petro in SPE. Another example or another application, you know that we use Thomas Steiber to identify like between the density in neutron and whatever the inputs you are using to identify, do we have the laminar dispersed shale. So what we have introduced here, one part of the enhanced workflow, instead of using the total porosity, which as I mentioned, or the volume shale, which is like has uncertainty regardless the density neutron is not fitting for the gas, or the volume shale from the gamma ray is not fitting or not providing accurate data on the kaolinite. So using the volume shale and the porosity with wrong grain density, because you have to get the grain density. Most of us, sometimes we are using just the one we used, the standard or the core for the first exploration well. So you have uncertainty in your porosity and you have uncertainty on your volume of shale. Do you feel that this will not create uncertainty to identify your type of shale? It is a laminar, structural, or dispersed. We proved and we showed that if we use the lithology independent NMR porosity and the volume of shale, which I showed you, which has less uncertainty, we will get accurate distribution or identification what kind of a clay we have. The one which everybody was asking, like, guys, maybe you are, we are okay to get like a free fluids, but sometimes your free fluids and permeability is not reflecting what we have actually. This is a tool limitation, or this is a technology limitation, or a resolution limitation. What I mean, maybe I was not clear. Permeability from, you know, like in turbidites, usually the thin lamination in deep in deep basin is like the permeability of sand is high permeable, but due to the resolution, you are getting average between the shale and the sand, so the permeability from the logs is low. Here we are reconstructing, we applied the similar technique of extracting the laminar shale volume from the NMR, and you will see that based on this model, you can get the actual porosity and permeability from NMR after excluding the laminar shale. This is the normal sequence of shale sand lamination and the tool vertical resolution. All what we did, we quantify using, as I mentioned, the shale volume and effective porosity, which is the lithology independent porosity, and the effective porosity in shale. We are able to identify the MBVI for sand, and from the MBVI of sand, we are able to identify the MBVM, which is the free fluids inside the sand. So just to avoid confusion, NMR can acquire based on the cutoff of which you mentioned you will provide it to service provider. He will provide you free fluids based on the cutoff you provide. But the complaint we received, this is why we enhanced this workflow, that while the NMR is a good tool, but sometimes it's not giving me the amount of free fluids. You can see the production is here is high, or the well test showed like high permeability, while the NMR showed less amount of free fluids and less amount of permeability. What we applied here just to exclude the laminar volume of shale. So a simple technique, this is the conventional one. We apply the cutoff for T2. Above the cutoff is the free fluids. Below the cutoff is bound fluid. And you can see that the porosity is for, after applying the excluding the shale, the total porosity is 4 BU, the 30 BU for the sand. And we have 4 BU for the effective porosity in shale. And the bound fluid for shale and sand is 4 BU. The same applied for the, if you are familiar about the NMR, you can see that the difference between effective and total, it's like about the cutoff. But if you exclude the amount of laminar shale inside the sand, you will see that the porosity, while we showed that it was in the conventional NMR, the MBH, the effective porosity 17 BU, after excluding the laminar volume of shale, the porosity is 30 BU. The same will apply for the permeability, because Baker Hughes is using quotes. Some of the other is using SDR based on each company. But if you look for the quotes, we are using the free fluids and the effective porosity. So if we enhance it from the previous technique, after excluding the laminar shale and enhance it or getting the real or close to the real sand porosity and effective free fluid volume, we are able to enhance the permeability as well from quotes. The conventional one is showing like 88 millidarcy based on the 17 BU, the conventional NMR porosity without excluding the laminar shale, and the constant of quotes equation, 88. If we enhance this by introducing the effective porosity for sand and the effective porosity free fluid volume of sand, you will see that we are getting about 3 Darcy. You can imagine the difference between your sand or the expectation or the evaluation. If you are getting, even the NMR is helping me, there's some free fluids here. But at the initial or a quick evaluation, 88 millidarcy with calibration might be will end up with 10 millidarcy, and maybe this is a very low permeability or low reservoir. But if you are talking about after excluding the shale, the volume of laminar shale, you are getting a 3 Darcy permeability. Even with calibration, what will end up? And will end up with half of this, one Darcy, but still you have indication that you have a permeable sand. So this is the example applying for the technique. This is the conventional NMR. The yellow color is the free fluid. The blue color is the bound fluid. Sorry. And once we apply you can see that how much we increased the volume of the free fluids using the reconstructed sand lamination. And this will change your idea of interpretation for the bottom part. Here is like, maybe it's consistent at the top part because more or less is a clean, but once you are getting dirty and there is a lot of lamination, your enhanced NMR free fluids and enhanced permeability will give you a different idea even than the conventional NMR, which is much better than the conventional density neutron as a reservoir quality indicator. So we are moving from step to step. And also this test, this zone has been tested, and the red one is the added BERF based on the NMR reconstructed. And even the conventional NMR can help for the top part, but the reconstructed NMR help us to add the BERF and add like 2,000 barrel per day for this for this interval. Maybe the question I will receive, and I'm just giving you an answer because I received in a several presentation, that yes, thank you that you enhanced the resolution from 2 feet or 1 foot to 6 inch, but my core sample showed me that I have a very small or very thin layer of sand, and maybe even with this resolution it will be bypassed. So most of you hear that the resolution of the resistivity image, electrical resistivity image, is 0.2 inches. And we use this resolution because we are able to get this one to make a reconstructed after enhancing all the volumetrics, introducing all the analysis. You can reconstruct your model based on the layer model built from the resistivity image. So this will help you to have more resolution for your data analysis. We are going step by step. We identified the anisotropy, we identified RV, RH, and RSAN. We identified the porosity, enhanced porosity up to 6 inch half full. And then we identified the free fluids. And even free fluid was not enough. We identified the reconstructed permeability to give a real permeability for the real sand lamina after excluding this. But still, we are talking about maximum 6 inch resolution, while there is something less than this. So utilizing the layer model from the resistivity image will help you to get a high resolution model for your lamina. And this technique has been published. It's not a new, but just like the change of introducing the dielectric and introducing the new NMR will help you to get much better. So each time we are moving a step towards or closer to the real sand resistivity, sand permeability, sand porosity. This is the main approach and target for us. So just the results based on this workflow is identify the sand resistivity and identify the sand porosity and permeability with a true resolution and identify the movable fluid. Once we identify the movable fluids and the true porosity and true permeability and true sand resistivity, we are able to update the static and dynamic model and enhance your resistivity calculation, and there are no bypassed hydrocarbon in the thin laminated reservoir. This is what, in general, the workflow starting from the tensor up to the layered model using the resistivity image. You can see we have applied this workflow or shale sand laminated in all over the world. We introduced this like since 2000, and everywhere we have applied. Even maybe we need to update. It's not only in your area, not only China. We have in Malaysian Sea deep turbidite. There's a published paper and a lot of work there in Saudi, Middle East, Mediterranean, North and South America. So, and most of the cases is published for review. I just like a few cases we have published with a publication reference. You can go through it, but you can see that we have like 20% increase in gas-based estimation for this example, or in deep marine turbidite. And in Brazil, we have like 40% additional reserve in deep water play based on this workflow and this analysis. And the same has been done in Malaysian deep water, as I mentioned, all the paper reference. The presentation will be shared with you later, so you go for this example. And also I will leave my email, any clarification, I'm ready to answer and to have a chat with you. So the conclusion conventional, I hope that I didn't bust the time. The conclusion, the conventional well logs are limited to evaluate the turbidite sequence. Multi-component resistivity is not enough to identify the potential movable hydrocarbon, because maybe we have R sand, but R sand is not reflecting the hydrocarbon, reflecting the tightness or something else. High sampling rate, and I need to specify this because I received this concern and complaint from several clients. High sampling data rate is not a high resolution data. Please just be careful about that. So the combination between multi-component resistivity, high resolution porosity, dielectric, and NMR log is the optimum answer to evaluate the turbidite sequence. Up to this one, I finished my presentation and I'm ready to receive your question and your comment, and I'm done.
Thank you very much, Mr. Ahmed, for your presentation. It's a very interesting topic there. Let's see on the chat room. We have one question first from Julianta. In your example, how much minimum kaolinite percentage to be detected by the NMR logs?
Very, very good question, because this is the one of the challenge to get the kaolinite in a high volume, which was like up to 13. We were able to do it because everything was calibrated with the NMR device on the lab and the logs. So the minimum we succeed to get it up to 3% or 2%, if I remember, 2%, which even I feel like maybe, but it is still not published yet. The spectral gamma ray bypassed this, and even the XRD, XRF just identify some good match with us, but this was the NMR. So the minimum one we have seen up to 3% kaolinite inside the reservoir.
Sure. Mr. Julianta.
Okay, thanks, Ahmed. Just addition to that, in case I have a combination, I mean, between elite and kaolinite, does it still give impact? I mean, at least I have for example, elite is more dominated by, I just have only 2 or 3%. So as you mentioned, it will affect. Can you give a more elaboration on that one?
Yes, yeah. The idea is mainly at the beginning, the idea was like published in 1998 with one of petrophysicists. He was able to identify that all the elite, maybe North Sea, has a certain T2, and all the kaolinite has a certain T2. So whatever the volumes, most of the time, because as I mentioned before, the T2 relaxation or the T2 measurement, it's if you don't have hydrocarbon, if there is no gradient effect, the most contributor or controller is the grain size. So you can see that from the elite to kaolinite and kaolinite to chlorite, we have a variation. So even with the presence for both of them, this is the challenge was on the qualification. To get like the approval with client like Aramco, I need to see both volume. Don't tell me that your NMR, which is like good to identify the bound fluid, maybe the silt as a kaolinite, and you will tell me that no, I need the same. If I have both, I need to see your sensitivity analysis for the kaolinite and the elite volume. So in the presence of both of them, we are able, because there is no overlap. If there's a elite, it will be located something, maybe I can give you a rough figure, about something 1 to 2 millisecond. If we have a kaolinite, something between 4 to 16. So if I understood your question correctly, in the presence of both, there is no overlap, and we can identify clearly both of them. Why we need to identify the kaolinite? Because what we have seen here, talk about in Middle East, the presence of kaolinite is blocking the permeability, and the normal gamma ray is not able to detect the kaolinite volume. So you can see the shale volume is low, and your permeability is varied. And what the variation on this, based on a lot of studies, the kaolinite percentage. This is why we are interested to see the kaolinite. I hope that I answered your question.
Okay, thanks, Ahmed.
Very good. The next question was from Didit Petronas. Have you tried compare SW from NMR? as per your explanation with SW from saturation height function? If yes, what is the process that you use for those calculation, by E or by T?
Okay, this is another very good question. Maybe the one has been not me, and it's like I will not take the credit for that. All the work done before, even like the example I didn't show you, like the conventional example without any lamination, and showed like how the NMR giving you the indication about the hydrocarbon. But don't let us, even if the giving a match with the study or the analysis in conventional sand or clastic, or even in shale laminated sand with height above or saturation coming from the height modeling, should not forget we are measuring the residual hydrocarbon. We are just giving like an indication. We are measuring in 4 inches already flushed zone hydrocarbon. So maybe it has some uncertainty. All the purpose of introducing the hydrocarbon is just a figure. Do we have or not? Like, if even if it's residual, there is a hydrocarbon, or it's just like a wet reservoir. That this doesn't mean that it's not matching. Yani, I have applied this not in clastic. I'm talking about myself. To answer your question, for shale sand turbidites, a lot of studies done between the core analysis and capillary pressure and height above saturation done there, and they have a good match. But I'm talking about my analysis in low resistivity bay in carbonate, which I mentioned in Middle East due to the micritic reservoir. And we got a good match between the dielectric hydrocarbon saturation, the NMR saturation, and the core analysis or capillary pressure height above saturation modeling. Yes, for the analysis I done. But this will not let us to forget that we are talking about saturation in a flush zone. I don't like to, even when sometimes I introduce it as a solution, but I have to be honest with you, this is just mainly residual hydrocarbon saturation.
All right. Did it? You want to still elaborate on that question, or are you satisfied with the answer?
I'm trying to get like to see the questions. Just let me
Okay, thank you.
So the next question is from me. Yeah, Mr. Ahmed, in many mature fields in Southeast Asia, I'm speaking on particularly Indonesia, where I belong. The many fields has been cased, and the provider has not identified the thin bed reservoir in the beginning, but they later down the road they start to producing this oil from this thin bed reservoir. In such condition where there is no advanced logs such as 3D resistivity or NMR whatsoever, what is the best approach to evaluate this thin bed reservoir to its potential without any additional advanced data, only open hole, conventional open hole data?
Okay, like even you can see that maybe I mentioned, but I can right now compile the answer. I have received this question a lot, but based on my real experience, I have done it maybe more than 15 years ago. And I done it not just like at this time, the triaxial resistivity was like still not like everywhere. NMR is limited or expensive at this time. So what I did, most of the companies, luckily that they can do this processing. I don't know most of them, but at least I'll talk about myself. You can enhance the density neutron porosity and acoustic porosity resolution. This is the conventional one. Even the old data, you can just ask your provider to enhance this. And for the resistivity, the only way to get this one in future, and maybe nobody done it, as I mentioned before, just instead of add the fancy log, just combine the induction and lateral log together to get like idea about the RVRH. And this is what I have done. And I done the same analysis, Thomas Tybor, volume of laminar shale, Phi max, everything I done it based on this technique. So this is the maximum you can get it, like to evaluate your thin bed analysis without at least like without suppressed resistivity, overcome the RVRH challenge and get the RSAN, enhance your porosity resolution. But right now, yes, maybe it looks like a fancy log, but the value I'm not upselling right now because everybody has, maybe you're not dealing with my company, but it's not with the current situation with the complicated reservoir, the triaxial resistivity, the NMR is not a fancy log. For me, I believe that the NMR it should be, from long time, should be the essential tool to be run and not the triple combo. NMR, you will get a lot of information about your reservoir, about your evaluation. So maybe I'm not like little bit disagree about the fancy log. Compared to the result and the reserve, enhance your reserve calculation will add more value. But if you don't have this fancy log, as I mentioned, the combination between lateral log and induction can help you to get the RSANT. The high resolution processing for all density or even the conventional density neutron and acoustic will help you to enhance your porosity resolution.
Sure. The next question from Pak Gede. The first question will be from Pak Gede. ADEX, ADEX dielectric tool is wireline or LWD?
Yes, I can see the question. The dielectric is right now, majority is wireline. It's because till now, 1 gigahertz in LWD is very tough in this harsh environment. The maximum you can see in LWD, you are seeing like something 2 megahertz. Maybe there is some trial we are working like to get like dielectric, but till now the ADEX dielectric is wireline for 1 gigahertz. Is ADEX shallow reading device? Yes, it is vary from 1 inch depth of investigation up to 6 inch, but similar to density neutron. I'm talking about like, yes, it's not deep like their resistivity, but up to 6 inch, you are getting an idea about your water filled porosity. If shallow, any issues over? Yeah, this is a good question. Maybe you are expert about the dielectric, but his question is mainly the oil-based mud is like all the signal we are getting will get from oil-based mud because the signal is very, very, very strong. So what we did, as I mentioned, sometimes when you come late, but you study all the challenges, the conductive formation, the oil-based mud media, you can overcome this challenge. It is a challenge for the acquisition, but for the fluid, we most of the time, based on the jobs we have done it, the only challenge not only the invasion happening there, because the radial profile showed us between the 1 inch up to 6 inch, you can see the difference between the invasion, and you can identify, do we have this is hydrocarbon coming from oil-based mud or coming from formation. But the major challenge which everybody is suffering is the acquisition itself, like to acquire the tool with OBM. So yes, we can do it in oil-based mud. How do you measure M and N parameters from? Yes. Okay. We are, if you are familiar, maybe this is like for detailed presentation for dielectric, but I can just simplify for you. In a dielectric, we are measuring a permittivity for the matrix and permittivity for the fluids as well. So the permittivity of the matrix, there is a mixing law called different mixing laws, not one specified. One of the constant of mixing law is a function of the bore tortuosity or the bore shape. If this factor is high, you have like a round shape. If this factor is low, you have a slim shape. So the current industry right now is providing, or current service provider is providing M equal N, which I'm not agree. And as a Baker Hughes, we are not agree about it because M not equal N equal number. M and N is not equal. Right now, the industry is delivering M and N based on this constant during the inversion. If this number is high, is reflecting this kind of bore shape, and you can understand your bore shape and your bore tortuosity. You can get M and N. What we are working right now to deliver from dielectric, and we reached it for the project. It's a collaboration project between us and Saudi Aramco to deliver independent M and N. So this is how and what the limitation for current methodology and how how to deliver M and N independently. Is it necessary to core calibration for right now to deliver M and N? Any new methodology has to be calibrated to the core data. What we are doing right now for the collaboration project with Aramco, we have acquired wells in different environment, different rocks for experiment, for field test. And we acquired this in the wells, they acquired the core. And we will have like a dielectric device on the lab with the measured data. And this is simply without releasing more information, how we are working to get M and N independently. Hope I answered your question. Yes.
All right. Pak Gede, if you want to add some more, please unmute your microphone. If not, we will continue to the next question. All right, I guess it's okay. Another one from Didit. For thin bed reservoir, as you explained, which one is better? Single selective perforation in sand only, or long interval perforation, perforate all the zone, including sand, shell, sheet, clay, lamination?
You know, like I'm not the expert with the completion and the perforation, to be honest, but based on the cases which we, you know, like I used to work for operating company for 8 years, but since I moved for service provider after this, in my experience, since like more than 12 years ago, I'm not like in interaction with the completion and this stuff, but based on the cases which we worked with our clients, that they are using they are preferring to perforate all the zone, because there is no risk for that. All the fluid there are bound, so you just increasing the exposure for your perforation, and no risk for any water to move. This is based on my understanding. Maybe someone else like to explain why they are preferring this, but based on what I have seen after we done the analysis, it's a long interval perforation, which include everything, and there is no risk to have like a free water or mobile water in the production.
Okay, Pak Gede, silakan.
Okay, thank you. Thank you, Ahmed, for your answer regarding to EDX tool. I think I'm clear enough for your explanation. But I have one more question. In order to calculate water saturation, any requirement and independent porosity measurement to quantify water saturation for EDX? Thank you.
Sorry, repeat the last part. I didn't hear it well. The porosity calculation. Sorry, can you repeat this, please?
Regarding to EDX tool.
Yes.
Do we need a porosity measurement tool to quantify water saturation?
Yes. Thanks. I should have to highlight, this is a very good question. Yani maybe for the non-dielectric expert, we have to highlight this. So thanks for bringing this up. Yes, I mentioned before that the dielectric is like more sensitive to the water because the permittivity is high, and we use this to get like the kind of water-filled porosity. But how to get the hydrocarbon saturation, as he mentioned, that we have to have a porosity tool. So this porosity minus this porosity, this is the volume of the hydrocarbon. If both of them is the same, so all the pores is filled by water or are filled by water. If there is a deficit or discrepancies, the difference between the water-filled porosity from dielectric and the total porosity is the hydrocarbon volume. Yes, we need porosity.
Right. So we still need independent porosity tool.
That's right.
Okay. Okay. Thank you. Clear enough. Thank you so much.
You're welcome. Thanks for this. Thanks. Really thanks. I forget to highlight this. Thanks.
Yeah.
All right.
Terima kasih, Adit.
Yeah, sama-sama Pak Gede. Again, Didit, you want to elaborate again, or is it clear enough for your side?
Yes, for a very nice presentation. Thank you very much for the chance. On the perforation, my question is, Yes, I have the example. I do long perforation when I have the low resistivity but very low permeability in my previous case. And in your slide, I don't know how many permeability that you have in the previous slide. May I know?
You mean the permeability on the previous slide, like
for your previous example, Victor.
This one or?
Yeah. This the you saying this additional perforation that produce 700 barrels, right? In which slide? Yeah, I forget that.
Maybe I can double because I just like got it from the published, but I can double check exactly and I will send it to the team and they can provide. I don't have the number. I'm trying to get it, but no, you can get like permeability at this time. Yes, sure.
Yeah, this is new insight for me lah. On the low permeability, it's okay when we try to make the long perforation. But my question, when we have like the good permeability but consists of the sand and shale sand, we only perforate in sand interval only. But it's, yeah, thank you. This is the new side for me that we can add the long perforation, although this is we have the good permeability too. Thank you.
No, thanks. This is what I was looking for. One of the expertise, like to help, like what the factors to decide here or there. It's required like one of the the production or reservoir engineering. So thanks for your contribution. Really appreciate it. Thanks for adding.
Okay, thank you.
You're welcome.
All right, thanks, Didit. The other question I have is in the well with oil-based mud system, where they run 3D resistivity logs. Usually they did. Usually they do this 3D resistivity log in this kind of oil-based mud system. So, what do you suggest running NMR logs as well? And what would be the value addition in running NMR? Is in such case, usually the fluid ID from NMR will mostly affected by the innovation fluid and the definition of oil in the reservoir versus the oil in the from the base from the mud will be blurred.
So just like, let me repeat the question, just I understood, like it's an oil-based mud environment and we acquired the NMR and triaxial resistivity or multi-component resistivity. And the question is like, how to differentiate between the filtrate or OBM filtrate and the true for hydrocarbon fluid. This is the question?
Yeah, typically what I usually see is that when you use the diffusion, T to the map, you cannot really see clear definition of this is oil from the reservoir or this is oil from innovation. If it's using oil-based mud system, this is a case where here in Malaysia where they run 3D resistivity as well as NMR, and NMR isn't adding much value in order to define the oil in the reservoir. Is there what's your comment on that or your experience?
Based on my experience, I have seen that the OBM filtrate, you can identify it differently. I'm talking about the 2D NMR. Maybe like we can share with the rest, like so everybody to be on the same page while we are discussing this. So here we are talking about like the 2D NMR analysis. So the oil line and the water line here. So in my cases, which I have seen it, like I have seen the filtrate above line. Why we are able to identify, maybe just like there's something wrong on the acquisition or the tool, why we are able to identify, and I'm believing on this because it's just like a simple explanation. This line has been generated or constructed based on a true oil lab analysis. But if you have artificial oil, like the oil-based mud and diesel, will not locate on the line. So will be above and below the line. And all the cases in offshore here in Saudi Aramco, when I'm doing this cross-plotting, I can identify this fluid or filtrate because it's artificial oil, so will not locate or overlap with the true oil, so you can see it. But let's say that we have overlap and most of them due to one reason, that overlap and not clear. There is, as I mentioned, maybe for the question for the dielectric, there's a individual frequency processing. So you can get the NMR at different depths of investigation. And based on this, you can identify the borehole effect. And also, if you done this analysis at the different depths, you can like see there is a variation on the filtrate, or there is no variation. But if normal case, the artificial oil, which is OBM filtrate, will not overlay on the oil line. This is what, based on my experience. This is the main differentiator. If it's not, whatever the reason, it will be like a hard job, even with a radial profile or residual hydrocarbon profile. It will be also difficult, not like the 2D NMR, which is located where is the oil and water. But for the cases, maybe you can just double check with them what was going on. Because I'm keep repeating, this line has been constructed for the true oil and not the artificial. Any artificial fluids will be located above and below the line, and you can easily differentiate this is a filtrate, this is a true formation oil. Hope that I answered this.
Very good then. The next question from Arga from Mubadala Petroleum. His question is to add more complexity on this topic. He has dealt with complex mineral composition in thin bed reservoir, where the minerals also affecting the logs reading. And the conductive nature of these minerals has given result of subtle resistivity response in gas reservoir, apart from the clay content effect. So he has clay, also the conductive minerals in his reservoir. And even the image log didn't help very much. And will the advanced NMR be able to help to at least identify this reservoir? But because this reservoir has been tested and it's flowing with gas. Mr. Arga Hilman, if you want to unmute yourself, please go ahead. Okay, I think Mr. Ahmed, you can answer his question maybe.
Now, this is why I at the beginning I start that this area of expertise, like I like the question, because sometimes when you are having all the ideas during the presentation, and even if you're having your side notes with a virtual presentation, but still you can skip some of the point. This is one of very good point, and I published paper for this. Yes, the answer for NMR is able to identify the reservoir from non-reservoir. He's giving an example, or I will share my example. It was like a conductive mineral, like a glauconite and pyrite, and it was laminated chili sand, and everything like was like conductive, like the sand filled by huge amount. We are calling green sand, glauconite. So even if you are able to get the sand resistivity, it is very conductive. And the density neutron, you can imagine, because there is no clear grain matrix, and you are using 2.65, and everything is affected. Glauconite, a lot of iron, a lot of Fe there. So, and pyrite as well. So your grain density is completely different than this, and you are not able to evaluate the reservoir. And maybe I can send you the paper which I done it in laminated glauconite sandstone, and the NMR is helping to identify the reservoir from non-reservoir, and it has been tested, and yes, there is a flow. We have tested the production. It was like bypassed because density neutron showed it's very shaly one, and porosity is low, and everything is not good. Just like to add something to avoid confusion. I don't like when you will go back, you will surprise. In my study, if you remember when I was talking about the gradient effect, and I highlighted it's an external gradient because we are using 6 frequency, and each frequency is acquiring at different depths of investigation. So there's a gradient during the acquisition. This gradient is creating diffusion. So I mentioned it's external, but there is an internal gradient due to the ferromagnetic mineral, like the conductive one, the glauconite. And this could be affecting the NMR. But the good thing that, which I have done it in my study, in LWD NMR, it is a single frequency. There is no external gradient. The only thing we feel that we minimize the effect on NMR. So the only thing we have seen it was like if my reservoir was filled by gas and oil on this paper. So the only effect was little bit effect from the internal gradient. And we identified on this paper like a variable cutoff for the NMR, and the result was great. So my recommendation, yes, NMR is helping to identify reservoir quality in such situation, and try, if this is the case, try to make it with a low gradient tool similar to the LWD NMR.
Mr. Arga, you want to comment more?
Yeah, thank you, Ahmed. That's a good news that we know that the NMR will be useful for this kind of cases. That was the exactly cases that I have dealt previously, where we have very complex conductive minerals in the reservoir itself, and it's also uh, combined with the thin bed nature of the reservoir. It makes us very difficult to evaluate with only just the conventional logs. So if you can share that paper that you mentioned just now, that will be very useful for us. Thank you very much.
I will share with Julianta the paper reference, and I'll do this, the LWD NMR. Sure, I will do that.
All right. Thank you.
You're welcome. You're welcome anytime.
Very good. Okay, from Julianta, this is kind of out of topics, but I guess it's still okay. Do you have experience in the application of NMR in basement reservoir?
Very tough question. No, to be honest with you, like I was like close to do it in Yemen. They have a basement and there, but just like a comment without experience based on the physics and the measurement. If we are talking about basement, we are talking about fracture basement. And in general, physics-wise, NMR, because the fracture porosity is low, and NMR required a sensitive volume. So volume, like volume of hydrogen to acquire this. If you don't have this, even in a fracture carbonate, we are not able to acquire the NMR because you need this volume. The porosity is very low, and you don't have this volume to acquire or to experience the NMR. If the fracture basement similar to the fracture carbonate, the answer no, the NMR will not help. But really, I was interesting, like before this event in Middle East, to test it in Yemen. But unfortunately, the things happen and I couldn't. But if it's the same fracture basement like fracture carbonate, no. With this very minor or small fracture porosity, there is no volume to experiment the NMR there.
Sure. Mr. Julianta, do you want to add some more?
Yeah, okay. Clear enough. Thanks, Ahmed.
Very good. The next question is from me. Mr. Ahmed, have you ever encountered reservoir biogenic reservoir low resistivity? And in such condition, what will be your approach on evaluating those kind of reservoir?
But if you can elaborate more about the biogenetic reservoir, just like to be on the same page.
Oh, sorry. I think I misspelled it. Bioturbetic reservoir, not biogenic.
Yeah.
Yeah, bioturbetic. Yeah, sorry.
Yeah, sorry. Okay. Maybe in the Mediterranean Sea, which maybe I can also like share it, but in this one is we are calling similar to the slump, like something you can get maybe for the non triaxial resistivity. You can get RVRH, but there is no this anisotropy not due to lamination, or even just like a slump or bioturbation. This is the question, and this is like a common feature there. So you will be excited once you will see this balloon of RVRH, and you have high anisotropy, and the R sand is high. But this is fake, because once you will see it's not permeable on there. The answer for the question, the NMR is helping that there is no free fluid, and we have done this, yes, in Mediterranean Sea. And it will help you, yes, this RVRH is not reflecting laminated shale sand sequence, and this is just like anisotropy due to the slump or the bioturbation, and there is no or zero permeability.
Yeah, thank you. Because I have experience in I think in Italia, so that they have bioturbetic sand with also sand lens structure in their software. So they have multiple advanced log-like image, and unfortunately they don't have 3D resistivity. but the NMR is helping a lot on that case. Yeah, thank you, Professor Ahmed.
Yes. Thanks for that. Yeah.
So I guess we don't have any more question. Audience, if you want, okay, another one. From Julianta, have you compared SW calculated from NMR alone and tensor resistivity alone from the tin bed?
Yes, yes, I have done it, and I get like a mismatch, as I mentioned, because the case in which I done it, there were like a kind of core data calibration, and the NMR was a little bit flushed, so it was like a residual hydrocarbon. But the good one was matching the area which is like I don't like to say that it's unflushed, but it was just like at the top of reservoir and all is SWIR. We have some match, but no, we have some mismatch between them because due to the flushing and the residual hydrocarbon calculation, not like a deep measurement.
Okay, so it's flushing because of the shallow depth of investigation from the NMR.
That's right. That's right.
Ah, I see. Okay. Okay. Yeah, just to check, because I compare using a conventional and then NMR alone and tensor resistivity. And as you said, more robust, I think, coming from the tensor resistivity.
Exactly. And in my example, it was a little bit late. Yani we run the NMR at the end, yani after like maybe 7 days. So everything has been flushed and left, and even borehole condition. Maybe if we have like a kind of while drilling or like make sometimes some clients knows that the NMR is confirmed. It's not like contingency, like based on the density neutron evaluation. They run it like at the early stage. So maybe this experiment will help you. But for the case of which I done it, it was like after 7 days, and the washout was like the diameter is high and everything flushed. Yeah, tensor is more robust at this case.
Okay. So in addition to that, okay, I think it's already asked before, just want to emphasize. So assuming we just have a normal triple combo and we're dealing with tin bed reservoir or turbiditic, etc. So what's your suggestion? I mean, what we can do more for our data set?
In maybe just like the same question, but you need like for future, the question was like for the existing technology. So for the future, and you don't like, there is no plan to run any other logs and you have triple combo.
No, not in the future. In the past, because so many logs in 70s or 80, they just run a normal triple combo, right?
Yeah, the old one, as I mentioned, maybe like not like you can like the technique is exist even for data to process to increase the resolution for the porosity, and I don't think that in the past or 1970 that they will run the combination between induction and lateral log. The conventional one is limited, to be honest with you. And if you have the old data and you have this lamination with small thin laminated reservoir with the old data, it will be very difficult job. Maybe the recent data and or future, and you don't like to run fancy log, and only it's a triple combo. The only thing that I need to recommend, add for the BHA or the string density lateral log and induction, and ask the service provider to provide you high resolution density neutron acoustic. Might be any like with some limitation, but will give you a kind of analysis for shale sand lamination or tripartite evaluation without the fancy log NMR dielectric. This could help you. The combination of lateral log induction will give you RVRH. High resolution will enhance your tensor and Thomas Tybor and your phi max and volume of shale. So maybe you can get a figure about that for that. But for the old job and old technology will be very, very limited. This is why we have bypassed oil a lot or hydrocarbon in these reservoirs.
Okay. And also for the high resolution VPVS, as you mentioned before, is it just for the qualitative or we can add into the quantitative calculation?
No, you mean like the quantification for the shale sand or the data of high resolution? The high resolution is quantitative or the interpretation? Which one you mean? The acoustic data itself, the high resolution is quantitative, or
Yes.
yeah, it is. It is. I have received this challenge from Saudi Aramco when I introduced this like 4 years back, and like he told me that you are not acquiring extra sampling rate, you are not, all what you are doing, he felt that it's like artifacts. And we done like a several experiment and the results, yani, I think we published, or yeah, it no, the conference has been cancelled. It was like in the last 2019 conference, and it has been cancelled. We will submit the paper for this experiment. Inshallah, I will send it to you about the experiment we done between, or to validate this, to make sure similar question like you have asked the same question from Aramco. It is just like artifacts, and I can trust it, or quantitative. And core data, high resolution image, while the other logs missed this, this processing, all the high resolution acoustics, DTC, DTS was matching with the core description or core analysis, and matching with the high resolution resistivity image. Yani maybe like this example, I hope that, but in the paper we have like a very good examples. Yani you can see here how the conventional one, and how like each lamina, it's even like here, you can see it's just like one beak for the conventional acoustic. With the high resolution is very a good match between the layers identified with the resistivity image. Yeah, maybe I spent a long time just because I excited the question. I received the same, and we proved it with several experiment to explain what happened. But the answer, yes, it is a quantitative, and we have the procedures to see if there's artifacts or not, but it's a quantitative analysis. So even if your question was like about the interpretation, if the data VPVS or DTC, DTS is quantitative and robust, for sure the VPVS can be used for the interpretation for the gas sand. And even for the rock physics modeling, if you are familiar, this will help the guy who's doing the inversion if you have this high resolution analysis.
Okay, so you mentioned here the DTC high resolution. I mean, this is coming from the tool itself. So
Yes.
the output is the normal DTC, and the other one is the DTC with the higher resolution.
Yes, we are providing a normal resolution and high resolution for the same data. So you are for example, tomorrow I acquired data with you. You will get the normal resolution, but you told me that you have high thin laminated bed, and the resolution for the conventional data for DTC, DTS is not good. So with the processing, we will get extra data, but the data was high resolution.
Okay. Okay, interesting. Thanks, Ahmed.
You're welcome. You're welcome.
All right. Is there any more question? We still have 15 minutes for the Q&A session. If you have any question, please type in the chat room. We're gonna wait about 5 minutes, perhaps, to see if someone typing in. Well, Mr. Ahmed, just while we're waiting, for the brief plot that you use, I think in one of your slides, you use the brief plot using the VPVS data. Is that brief plot also useful in the carbonate reservoir as well, or only applicable in the plastic reservoir?
You know, like the standard one, this is I have seen it like in the standard one is differentiate between the plastic and like maybe you can see it like carbonate. But based on my experience, it's ideal because it's built that your VPVS for sand filled by hydrocarbon or gas there. I can see it is limited for carbonate. This is the answer.
I see. Good. All right, I don't think we have any more question on this presentation. It's very good presentation, Mr. Ahmed. Very useful for us, and I learned a lot. I think I give it back to Mas Julianta so that you can close this. Thank you, Mr. Ahmed. Shukron for your presentation.
Thanks a lot. You're welcome. Thanks.
Yeah, pass it on to Mas Julianta. Go ahead, Mas Julianta.
Okay, thanks, Mas Adit, and all participants. I think this is an excellent discussion between Mr. Ahmed and us, and hopefully we can get some added knowledge to everybody. And again, Ahmed, on behalf of SP Java and ISPG IAGI,
Yeah,
I would like to express thanks to you, and hopefully the collaboration can be continued for the next. And I think that's it. And to all the audience, thanks, because you can spend your time and join this discussion until end. And hopefully we will record this video and upload in the SPE Java and IAGI ISPG YouTube channel. Again, thanks everybody. Stay safe in the pandemic COVID-19.
Thanks, Julianta, and thanks for everybody. Thanks for the opportunity. Really, you are active to, and he was following, like he was patient and changing the time. So really, you are lucky to have him on the committee. And I appreciate the opportunity you give it to me, because I like to present between such expertise. Inshallah, we will repeat this in a different event and different topic. And really, I appreciate this opportunity. Thanks a lot.
Inshallah. I mean.
Okay, I think this is time for picture for us. Everybody can show up in the video. Then Bavanya can help to take picture. Please open the video.
Okay, I guess that's okay. Smile in 3, 2, 1. Say cheese.
Yes.
One more in 3, 2, 1. Okay.
Okay, everybody. Again, thanks a lot. Stay safe. See you in the next topic. Thanks, Joseph. Thanks, Ahmed, and everybody.
Bye.